I've got a few things on the board. Just in terms of review, because of the application that comes in terms of what we're going to be looking at today. The geometry book that you guys had a neat thing with 4 things you could do with triangles. One was the in-center. And that's, to get the in-center, what you did is bisected each angle by paper folding. You folded that angle, split this one in half, and folded it, and this other one, and you got a point in the middle. What would that point do for you? What is the application of in-center? Pardon? No, you can't balance it. By the way, you save that answer for me. Okay? Because that's where I'm going. Nice point. You're 3.5. Oh, what does that in-center do for you? When you put the compass point right on there,
you draw a circle around it.
Yes, you draw a circle, and it's going to be inscribed. Okay, got it? That's one. And you can do it all with paper folding. Okay? The next one. This is not the one. Yeah, circumcenter. Okay?
Circle around it.
Notice what I'm doing. I am doing some kind of averaging stuff. I'm going to take the midpoint in here. Midpoint.
Yeah.
And this way, midpoint, fold, and then you get, ooh, this is probably even going to, this could even be on the outside. And this is going to be a circle around the outside. A couple of very practical things in terms of life. Okay, then we had an orthocenter. What does that do? That's when I went from this point to put it this way down here like this. And what kind of angle is this? 90. And what does ortho stand for? 90? Yeah, orthodontist. Getting your teeth straight. Okay, what is guys, what's the application of this one?
Area.
Find area. Okay, then we have this one, and that's what we're going to be working on a little bit today. This is a centroid, and the centroid is by paper folding again. You fold it and find the midpoint of this side, and then you fold it to this point, midpoint to this point. Okay, and then Kinza, what is the application of that? That's a point that it'll balance. Okay.
Bang.
That's pretty nifty.
I did it very quickly, so now fell. So that is the gravitational center. And what we're going to be doing today is doing some things not this simple, but the application is finding the gravitational center of objects. Although we're not going to be at it today, we're just doing some of the things that apply. I also had something else here about a centroid that you had. Can anybody give me another bit of information about that triangle? There's another bit of really interesting information there that works for geometry.
Can we find the centroid of like the center of gravity part of a human?
Of a human?
Yeah.
Oh yeah.
If I fold them in little pieces.
But okay, now, can you kind of see how difficult that's going to be in terms of we're not just nice little squares? The scope of our book, although I don't think we're going to get it at it this semester, is we'd have to have everything that's the same thickness all the way through. And then we could have different shapes and sizes and then calculate where it is. Okay? What do you know about the distance from here to here and then the distance from here to here?
Half that.
Okay, now I heard a couple of explanations, and I think both people were right, but they described it very differently. This one is twice as long as that. Yeah. This is one from here to here. This is 1/3 of the way. That's 2/3 of the way. Okay, James, did you ever study that kind of stuff? Don't remember. Okay, maybe you didn't. The book that these guys had was a very, very good book. And it developed these, and it also developed it with paper folding, which is kind of neat. And in that, it was good for you guys, but it's good for a large group of students taking it, not just those who excel in mathematics. Okay. The next thing I'm going to do is this. I would like to know what the average is when I take 2 points. Like, I don't like this pen. I'll just check here just a second. If I have 2 numbers, what's the average?
Both of them plus each other divided
4.
by 2.
Okay, so the number is going to be 4. And if I have 2 numbers, as you were going, it's B plus A divided by 2. What if I had a C number?
B plus A plus C divided by 2. 3.
Okay, kind of get that. Questions on that?
So there's
Okay,
1 minus
now
B minus
this number we get here is the arithmetic mean. Okay? Now you about guessed it. We're going to try to put an infinite number of points over there pretty soon. Okay? But we'll get there in a moment. You've also done a couple other things with means. You've done it geometric, like this. 2x equals x over 8. What's the geometric mean?
4.
4. Okay? 2 is to 4 is 4 is to 8.
Oh, yeah.
Okay?
Yeah.
And so we have here A, x, x, b. This times this is AB equals x squared. So the mean is going to be equal to the square root of AB. Okay? So that's a different kind of mean. I think it was 2 tests ago in Algebra 2, I took the kids, and we hadn't done much with it. I took them to Denver and back. And to Denver, we went 50 miles an hour.
Wow.
And back from Denver, we went 70 miles an hour. And we said Denver was 700 miles. And so the trick question is how long it take up and back. You know, that was really easy. And then the trick question was, what was the average speed? You went there 50, came back 70, so the average is?
Not 60.
It's like
That's it.
64.
Those are the dark.
58.
Those are the dark.
Okay, now that's really easy to calculate for there, but I also taught you this last year, and that was the harmonic mean. And if you have 2 speeds like that, you go 8 times b all over a plus b. That is the arithmetic mean, or the harmonic mean. Did I still say it right? All of a sudden it looks wrong.
It's 1 over.
Yeah, that's right. That's a harmonic mean, okay? And which is kind of interesting. So now we have got those things. Now, how do we go about finding the mean of a whole bunch of points? So here we go. Watch what happens here. And yeah, I heard that too. Again, you see this nice little thing here. We're going to call this point A, and we're going to point this B. And now I'm going to write it out a little bit in terms of what we have been doing with our Riemann sums. Okay? So I'm just going to put a few points here like this, and here, and here. This is going to be x of 0. This point is going to be, that right here, is x of 1. That one is x of 2. This one is x of 3. Okay? And over here, we have x sub n, and this is going to be x of n minus 1. You with me? Yes?
Is this a proof we should write down?
It's not a proof, because the book is going to define it. But it's really a nice development, and you're going to see how we use Riemann sums mostly to develop neat stuff. Not to do our calculating, it's just to develop neat stuff, okay? Now, I'm going to add all these numbers together, and what I'm going to do is pick a number in this interval and add this one to it. And I would like to figure out here, like this now, what all of these, if I add all these up, what's the average? Are you with me? Okay, now, so let me just go and add these up a minute. And this is a point in here which we're going to call f of x sub k, and it's in that interval, in the kth interval. Now, I haven't been developing these very much. Maybe I should have. I'm going to just call this x sub k, and that's going to be x sub k plus 1. This is the kth interval, and so, and k can be any number. So it's in this line in that interval right here. Okay? So, questions at this point in terms of just what we're going to be trying to do.
Yeah.
So I'm going to add all those up, and so here we'll do that very quickly. I believe I've got this. This is okay. I'm just going to do it like this, and I'm going to go k equals 1 to n. Okay? Are you with me on this? And now, I would like to know in terms of how many we're going to do here. I'd like to find out what delta x is, in other words, the distance here. And so I'm going to do this. B minus a over n is equal to delta x. Any questions about that? Okay.
Makes sense.
Now, here I've added them all up. So I would really like to take this and divide it by n. With me? Any questions? Just a simple averaging kind of thing. We started with it a while ago, and now I have. What do we always do? We want an infinite number. And so we're going to go here. Just a second, what I have. Yeah, n approaching infinity. I think I'm okay. Any questions about this? Now that would be quite a bit of work, but look what happens out of this. I'm going to change this around, and I'm going to do it this way. I'm going to make this b minus a over absolute value, or excuse me, over delta x equals n. Any questions about that? Any questions? Okay, then what I'm going to do, I'm going to get rid of this little m down here and put what it's equal to. And so I'm going to put b minus a here, is that all right? And this will be down here, so I'm going to put it back here. Any questions about that? Okay? Now, I don't really like it over here either, so I'm going to put it up here like this. Any questions about this? What is this defined to be?
A.
The average.
Isn't that cool? Okay? So I've added all of them up, and in a sense, an infinite number, and it turns out to be the interval. So I haven't messed with all this.
Why do you have the 1 over b minus a out front there?
Because it was in the denominator over here.
That was your. Oh, okay.
Okay, now, are you following Grant's question?
Yeah.
To get it out here, Tanner, this way, because this doesn't have an n in it, so the limit here is not being affected by this at all, so I can put it out as a constant out in front. Yes?
So what is it that we're finding here?
Oh, we're going to find the average length of all these all the way.
Okay.
Or in other words, in a sense, what's the average area? Or what's the average height?
Okay.
What's the average height? All the way through.
Why would we need to know that?
For Tanner's idea, what is the center of mass of the human body?
Oh.
Or you have a race car, and you'd like to bring that mass center of gravity, as low as you can. And if you could accomplish it below the axle, you would really have something that's almost impossible to tip over. Okay, and so this is getting us ready for looking at center of mass and things like that, and some averages. Okay, now, any questions? Now I'm going to do a couple things with that, and then I'll show you in the book about a few things. Oh, Mrs. King, you are. Yeah. No, yeah, just, hey, I can do it up here. I had it on real. No, I just want you to feel guilty at this point, that's all. No, just keep working. I had a. No. Here we go. Here's our equation. F of x equals 4 minus x squared. And I had this graph very beautifully in black. And then I had a line across it. But anyway, again, just to make her feel guilty. Here we go. Now I'm going to graph this thing, but I'm only going to graph it on this side, and it's going to look like this. Okay? And so this is going to be a 0, this is going to be a 4, this is my f of x, my function, and this point is
A.
2.
Okay.
Okay? Now, what I'd like to do is to find the
So you still open letters now.
Riemann sums of those things. And so what I'm going to do is I'm going to put out in front 1 over b minus a, which is 1 over 2. Any questions about that? Okay, and then I'm going to do an integral. And I'm going to go from 0 to 2. I'm going this way. Now, okay, hey, yeah, you're laughing, but I've got a point here. I don't quite dare to pull this off yet. But he said 4 because it also makes sense doing it this way. And then we rotate. In one of these days, we'll start working on the y-axis like we're working with the x-axis. And again, it's another one that just does tricks to your brain. Okay, and this is going to be 4 minus x squared dx. Okay? Now that is going to give me the average length of all of these. The average. Okay? And so here we go. This gives me 1/2, and the antiderivative of this is
4x minus x cubed over 3.
which turns out to be 1/2 times 8 minus
8/3.
Okay, and then this is zeros. Yes.
Where did the 1/2 come from?
Where did the 1/2 come from? Please tell us where the 1/2 came from. Yes.
On the x-axis, you do the 2 minus 0.
Because the b.
Okay. Now, this turns into 1/2 times 24 minus 8 over 3, which turns out to be, I think, 8/3.
How do you get the 24? What do you?
He times it by 3.
Common denominator. To add, subtract these two numbers.
How do you, okay.
Yes?
So it's 4 minus 2 or 2 minus 0?
It's 2 minus 0 because it's on the x-axis. You're taking it from the beginning point to the end point.
Okay.
Yeah, we do that. And certainly it doesn't bother. Oh, okay. Now, we'll take a quick peek at this, and let's see here. Yeah. We'll see, as we said in the dark.
Holy cow, early out.
Yes, 15 minutes.
Okay.
I was past iron.
Notice what I have. Here's the function, and I use this notation here so that I don't have it on this side. It just starts over here. And so I thought that was cool. And you see the 8/3 here, and so you have this line. And so the average of all of these turns out to be 2.667. Okay? Now the next thing we want to do is, where does that happen on the x-axis here? In other words, right here. And here we can just read 1.155. Okay? And so let's go find that point in a minute. The next part what we have to do, this is game you can shut it off now. Nope, done. Don't need anymore. They all remember the number. Okay, now, watch what happens here. We don't need this anymore. This is part now of mean value theorem for integration of averages. We'll show that to you in a minute. We noticed that this line here, this point was 8 over 3.
Don't like that smart tone, Jeffrey.
We're used to that, Mrs. King. Okay, now, I would like to know where this happens in terms of the x-axis right over here, and we know it's going to turn out to be 1.15, and so we have here 4 minus x squared equals 8/3. Understand that? What we're doing? So we have here 4 minus 8/3 equals x squared. And so this gives me 4/3 equals x squared.
What?
And so x equals 2 over the square root of 3. Questions on that? Okay, now, let's, a couple things in that chapter I want to cover with you so you can see what happens here. Page 351 at the bottom. The average value of a function. The average value of a function is given there, and we developed it. And I think the way we developed it should make it that it's kind of meaningful. And you get some ideas of how you could use it, okay? Then, on page 353, the mean value theorem for integrals. That's what I just finished doing, okay? Where is that C point in between here? That was 1.15. I'd love to talk longer, but if you understand it, why bore you? Got it? Okay, so you're going to be doing some of those things. Okay, in terms of the assignment, there are a few other things I want to go over yet today. On page 355, you have the arch in St. Louis. How many of you have been up there? It's not very much fun going up in those
It's
tiny
so
little...
small. And then the window is like an inch big.
Yes. Okay. The problem is quite easy. Guys, hey, the problem is quite easy. Okay, the next thing I want to do. First part of this chapter, this section, I mean, has odd and even functions. So there are a couple of things I want to do there yet. And let's start with even functions. And here's the definition of an even function. F of x equals f of a minus x. Very handy thing to have around. Give me an example of an even function.
X squared.
X.
Oh, I like it. You're
Good job,
great.
man.
F of x equals x squared. Another one. That's
X to the 4th.
okay. How about this one? X to the 4th plus, oh, like this.
That's a 2.
There we go.
Yes.
Yeah.
Okay, that one is 2. How about this one?
Yes.
Uh-huh.
This, all this did is moved everything up, didn't move it over. How about this one?
Mm-hmm.
Okay, and you can put coefficients in front of these. Those are all even. Yes.
But, okay, if that's the derivative, do you take it as the derivative is even or the antiderivative is even to find you know what I'm saying?
Yeah, I know what you're saying.
Jeffrey.
I don't know if I want to go there very much.
Don't, please.
Okay,
But you have questions
Yeah,
on
okay,
this problem.
yes, right,
I mean,
okay,
it's assigned like
yeah, okay, like this. This is what I'm talking about.
Yeah.
The integral. So the antiderivative
Is x cubed over 3.
yeah, yes. Okay, now, we aren't finished with these yet. Here's another one. G at x equals, how about cosine of x?
Sine of x.
No, sine is odd.
Oh, sorry.
Sine is odd. Okay, so now we have these. Look what happens when I do this. I'm going to go from A to A.
Whoa.
In other words, minus A to positive A.
Oh.
Okay? So what I'm going to do is this. This will be a quick one in terms of x squared dx, like this. And if I went from a minus 1 to 1. And what this thing is supposed to show you, well, here's the graph. We have this. Okay? And we're figuring this area here and this area over here. Are you with me?
Positive.
Okay? And so we could have said that's 2 times 0 to 1 of x squared dx.
Nice.
Okay?
So then
Just
what?
do it from here to here and it's double.
So then you just put a 1 in for x, or do you have to take the antiderivative? So.
You still have to take the antiderivative.
Okay, and
Yeah.
then you put a 1 in.
And see, this is okay. This is just interesting.
Yeah.
Let's go to the odd ones. They're much more fun.
Well, don't they all equal 0 though?
Oh, okay. Listen, here's the neat question. Where do I get the 2 from? Okay, this is one half of it, here's the other half.
Okay.
And instead of going from here to here, I go from here to here. Okay? Now, let's now go to the next group, which are the odd ones. And that's f of x, and this is how I often write it, this way, but more books write it this way. F of a minus x equals negative f of x, this way. They're equivalent, okay? Now, and the nicest one here, I'll just give you one to start with, is like x. And it goes this way, and you'll notice on this side, you get it over here, and now on this side, you're over here. Okay? And another one is the sine function, which I said a while ago. And x cubed is another. And tangent is another. Now watch what happens with this. Okay? I'm going to take the integral, and I'll just do an x to start with. And from a -2 to 2. And oh, Jeff has already got this done. He's finished, we're done. Okay, got that finished. Okay, now we're going to try this one. We're going to go pi halves minus to pi halves positive, and we're going to go sine of x.
0.
Okay, got that? Now be careful with those, because you're going to get some problems where sometimes you can just take a piece of a function out and dump it. Okay, as an example like this. What is the derivative from a -2 to 2 of x squared plus x cubed dx?
X cubed over 3 plus x4 over 4.
I just throw this away. Because see, now we haven't done a lot of this, but the integral of a sum is a sum of the integrals, like this, see? dx plus, like this, x cubed dx.
So you can do that before you find the antiderivative, is just take out the 0 if it's an odd.
Yes.
And that's the derivative is an odd. Okay.
And you can imagine what fun I would have by doing this and using a sine over here or a tangent here that's really miserable. Okay? And if you didn't identify it, you would have a terrible tussle. If you've not identified it, you dump it. Such as this. What is the integral from pi halves minus to pi halves positive of x squared minus 14 sine to the 7x dx?
Just get rid of the 14 sine 7.
Yeah, this you'll just throw it away. Because these are going this way.
Uh-huh.
Okay? So be careful on that. Okay?
7.
Let's see.
Could you do 7?
No,
Yeah, do 7. No.
Well, what do you have? Is it different for
I'm not
symmetry?
finished. I have a part to do yet. And so if I have time at the end, I will. Okay.
Chill out. We're going to spend some time. Oh. How are you going to deal with this problem? And I'm going to teach you how to do this with substitution. Tomorrow, I'm going to show you how to do substitution in a bigger and better way yet, although we'll incorporate everything that's here. Now, you could multiply this all out. That isn't all that terribly hard, but it would take you probably 15 minutes or more, okay, to multiply it out and then find the derivative. But you can do it by U substitution. Now this is the indefinite integral. The definite will work just as nice, but at this point we don't have any values here, that's why it's indefinite. So we have a C at the end, okay? So what I'm going to do is this, watch what happens. I'm going to, now watch carefully so you get the idea. It's not so much different than we have done before, but I'm going to make u equal to 2x plus 1, this quantity right here. So du equals 2 dx. Are you watching? Okay, yep. Now, this here and this is going to be a what? That's a du. And what's this?
U.
And it's going to be u. What's the antiderivative of this?
U cubed, u to the 4th over 4.
Yeah, done.
And so my answer is going to be 2x plus 1 to the 4th
Over 4.
over 4 plus a constant.
Whoa, that was easy.
Now, let me show you how this works when I undo it. What happens when I take the derivative of this? The derivative of this quantity is this, 4 times 2x plus 1
To the 3rd.
to the 3rd.
Times
There's a
2.
4 down here. Times what?
2.
Times a 2. Okay, and this is going to be plus 0. Okay, these cancel, and you notice what I have here is exactly what I have up here.
Is it always the case?
Pardon?
Will that always be the case?
Only a select few problems like this. Life in the area of integrals is an experience.
We can hope.
Okay? Yeah, you can hope. Okay? One more. One more. We're going to go this way, and I'll go x cubed times x to the 4th plus 6 raised to the 9th dx. Again, you could multiply this all out. This time, I think it would take you an hour or more.
Wow.
Yeah, okay, good. You do that, and I'll check your.
Wait, what do you mean multiply it out with the x or like?
The whole business. This is x to the 4th plus 6 times x to the 4th plus 6, doing that 9 times over, and then
You just plug that in.
okay, here. So we're going to use u substitution. U substitution. U is going to equal what?
X to the 4th plus 6.
What does du stand for?
4x plus sorry.
Okay, got that?
Yeah, I do.
Please elaborate.
Yes.
We're doing the derivative.
Okay, now what I'm doing is something like the chain rule, but notice what happens here. I need an x cubed, I need a dx, and I need a 4. I got this here, I've got here, but I don't have a 4.
Where'd you get the 4 from?
Here.
Whipped it out of nowhere.
Alrighty.
Now what am I going to do?
Doc Kramer.
Well, I know how to fix this up. I'll just put a 4 here. And I'll put a 1/4 out here. What's 1/4 times 4?
1.
You have noticed that we've done this so many times. Okay, now you see this here is going to be a du. See that? Right here? And what's this? Don't forget this 1/4 out here. Questions?
Then can you write it out?
Yeah. Okay, what's the antiderivative of that?
Yep. That's what I thought.
Exactly. Yeah.
Okay?
Yep.
So it's going to be 1/40, and I need to substitute here x to the 4th plus 6 to the 10th plus a constant. Yeah.
Can you do number 7?
Okay.
Yeah.
Any questions now on u substitution? Jason, I see you have your glasses. Number 7, you said on which page?
Okay.
354. Number 7. Okay.
Mr. Kramer? Okay, this is kind of off subject, but when is our exam?
I have no clue.
Yeah.
With the way our scheduling is going, this is the 3rd time at least I've prepared for this lecture, and everyone had to change because of all different kinds of time constraints.
The snow.
That's too.
So, anyway, number 7, here we go.
On the YouTube.
Use the symmetry to, okay.
Yeah.
Is that problem even or odd?
Even.
Even. And so, it's not terribly helpful that it is
It's 1,000.
use symmetry, so I'm going to do it this way. 2, and at least so I'm using symmetry, I'm going to do this. 3x to the 8th minus 2 dx. Now, in this case, there's 2 is out here, and then I'm gonna go, what's the antiderivative of that?
3x to the 9th over 9 minus 2, or x, yeah.
Okay? And I think you can handle it the rest of the way home, can't you?
No, because it doesn't give me a right
Okay,
right
this
answer.
here goes out here, and this is a 3. Okay?
Yeah. Wait, what?
Okay? Because it's 3 over 9. And so this gives me
Oh, okay.
2 times 2 to the 9th. I don't know what that is off the top of my head.
It's,
Over, okay, I better do it this way. What did you say it is?
Hold on, give me a sec. It's 512.
Okay, I think I've got everything here like this. So this is 2 times 512 divided by 3 minus 12 over 3 equals 0, I believe. Yeah. Oh, that's cool. So this is 500 over 3 times 2, so it's 1,000 over 3.
That's, if you don't know what you're doing there, you just vote without a paddle.
Yep. These people are interesting. Every time you come in, they just are at their best. DeVries.
Can you do an average values problem?
Like what?
Like which one?
23.
23. Okay, let's take a look at that in a minute. We have a little time. 23. We have f of x equals x to the nth, and we're going to do from 0 to 1. And what's true about n?
It's positive integer.
Okay, and it says find the average. Okay. So we're going to go 1 over what? Boring.
1.
And we're going to go from 0 to 1.
1.
And we're going to go x to the nth dx. Okay? That's going to turn out to be x to the
M plus 1.
over
And plus 1. Yeah.
So it's just x squared over 2.
1.
Oh wait, you put the 1. Never mind. Yeah. 1 to the m plus 1 over m plus 1. Okay.
And that gives me just 1 over n plus 1.
So you can't do anything with the ends, you just leave them.
I don't think so. Is that what he has in the back?
Probably.
You don't look to the back.
I know.
No, we're not that kind of student.
But how do you get it?
Never.
How do you get the N out of the top there?
Yep, that's what you have to
Isn't
do.
it still just no down? The on your final answer, how did you get just the 1 as a numerator? Because
Okay.
you get N to the 1 to the N.
1 times 1 times 1 times 1 is always 1.
Okay. But could N be something else besides 1?
No, here n represents counting numbers.
Oh, like N. Okay, yeah. All right.
Okay, like Angie.
So we're putting it out on the shelf.